The distributive law says that we can distribute something that's multiplying two things adding together. So this can distribute into here like this. We're going to multiply each of these terms by a. This works as well if a is on the other side. It still distributes into the addition. So we're going to have a times b plus a times c. We're just multiplying each one of these things. We can prove this true for a simple case by just showing it and proving that these two sides of the equation are accurate. So -5, b is 2.4, and c is -3. And we're saying this is equal to this one here. A times b, a times c. All right. For this one, right, we're going to use order operations. Same, we have to do this inside bit first. Plus a minus means we're going to make that into just a minus. We start at 2.4, we move left 3 units. That's going to put us down to -0.6. And then we can do negative times negative is positive. It's going to be positive. 5 times 0.6 is going to be 3. Here, we're going to do multiplication first before we do addition. It's going to be, let's see, negative times positive is negative. 5 times 2 is 10. 5 times 0.4 would be 2. So it's going to be 12 in total. And then plus, it's going to be negative times a negative is positive. 5 times 3 is 15. Here you have plus to plus. That's the same thing as just plus. And 12 plus 15. So we start at -12. We're going to go right 15 units. That puts us at 3. You can also do 15 minus 12. It's the same thing. And you see 3 equals 3. That's a true statement. So we proved it true for this simple case. But in general, you can prove it true for every single case of any 3 numbers that you choose for A, B, and C. So what this means is that we can just distribute this into here. And we're going to distribute it into the numbers, right? This is going to be multiplying here. So this is going to be 7 times -4, which is multiplying x. Since they're right next to each other, that means they're multiplication. Then 7 times 3 times y. Positive times negative is negative. 7 times 4 is 28. Times by x, well, that's just going to be x here. 7 times 3 is 21. Times by y. It's just y there. So I'm multiplying 7 into -4, which gives -28x, and 7 into 3 gives us positive 21y. All right, for this one, we can distribute this into each one of these terms. It doesn't matter how many you actually string together. You're just going to distribute it into each one of them. So we have -0.1 times 18.3 times a. Then -0.1 times 2.45 times b. And then we have -0.1 times 0.007. All right, we can multiply the numbers together. This one here, right? This one has positive and negative, makes that a negative. And negative makes it a positive. Negative times positive is negative. 0.1 times 18.3 is going to be 1.83. And the a is just strung on there. This is negative 0.1 times 2.45 is 0.245. And b is just on the tagged on there in the end. And this is positive here. This is going to be 0.1 times that. It's going to be 0.0007 as a result. That's the distributive law. Just multiply it into each one of the terms and simplify it down. Now, we've already talked about solving equations, but remember, to solve equations, you get the variable by itself, and you always use the inverse operation to do it. Here I have x. I'm adding on to that 24.3. So to get x by itself, I need to subtract 24.3. Plus in a minus, plus 24.3 minus 24.3, we're canceling that out. And so we get left with just 900 minus 24.3. And the calculator says that that's going to be 875.7. So that's what x equals. Now for this one, we have b minus 1/2. To get b by itself, we need to add 1/2. Minus 1/2 plus 1/2, it cancels, like it gives you 0. So I'm going to add 1/2 here. What that gives me is 7/8 plus 1/2. I need to have common denominators. Which gives me 11/8. And that's what b equals. So b is 11/8. Okay, here I am multiplying, right? This is 2/3 times k. To get k by itself, I'm going to divide by 2/3. And we're going to divide by a fraction, which is the same thing as multiplying by the reciprocal. This is just 1/1, which means k equals just 3/2 there. 1 times 3 is 3, 1 times 2 is 2, so 3/2 is the answer for that one. And here I am dividing the variable by 2.7, so to get rid of this 2.7, I need to multiply by 2.7. That will cancel with that, leaving in by itself. So I'm going to multiply by 2.7 here. That's going to give me 1,000 times 2.7 is, let's see, 1, 2, 3, 1, 2, 3, 2,700. That gives me in by itself. So these are what are called single step equations, where there's only one thing you have to do to get variables by itself. We can also solve for general, but here we're only going to be looking at two-step equations, which is where we have to do two things to get the variable by itself. Now, if 3x plus 1 equals 10, then we can guess this, right? 3 times 3 is 9 plus 1 equals 10. So x is 3. That solves this equation. But to solve this algebraically, I'm going to use backwards order of operations. So the first thing I need to get rid of is the addition and subtraction, right? Order of operations is gamma. So we normally go this way, but we're going to go this way to solve for a variable. And that says addition and subtraction is taken care of first. And that's going to be this 1 here. I'm going to subtract 1 from both sides. So it's going to look like this. 3x plus 1 minus 1 equals 10 minus 1. Those, of course, cancel, giving us just 3x equals 10 minus 1 is 9. And here we have a one-step equation, just like we just did. I need to divide by 3 on both sides to get x by itself. That will cancel there, and 9 divided by 3 is 3. So that's our solution there. So doing the same process here, gamma backwards, I have the variable term here, and addition and subtraction onto this is done first. Well, we have this term here. Now this is a positive number. Since nothing's written there, you can write a plus in front. So this is actually adding onto this variable term. So I'm going to get rid of this first by subtracting 2.56. And so that gives me this negative 49.1z. And then I can just use a calculator for this. They're both negative, so they're going to add up actually. It's going to be negative, and then gives us 104.03. You can think of this right. We start at negative 101.47. We're going to go left or go further negative 2.56 units. So that just adds these two things up to get us there. Now, to finally solve this, I need to get the z by itself, and this number is multiplying the z. So we need to divide by 49.1, or negative 49.1, I should say. That way the whole thing cancels, and we're left with just z. Negative divided by negative is positive, and 104.3 divided by 49.1. I'm going to round this to two places. 2.12. That's my solution there. Okay, for this one, same process, order of operations backwards, addition and subtraction done first. This is adding on to this one, so I'm going to subtract. I still have this d over 7, or negative d over 7. And 296, that's positive. I'm going to subtract or go to the left 1,056 units. So it's going to become negative. 294 minus 1,056 is negative 762. To get d by itself, I have a division here. So I'm going to need to multiply. And I'm going to multiply by negative 7. Since I can move this negative down here, right? Be negative 7. If I multiply by negative 7, those will end up canceling each other out and leaving me with just d by itself, which is what we want. So I need to multiply by negative 7 here, and I get 5,334. So in general, you're going to always take care of the term that doesn't have the variable first, and then you're going to take care of the term, the factor that's multiplying the variable. Backwards order of operation is key.